I got all the numbers that we like here. And
Okay.
so I sent them a message and we'll be looking into this, but do continue on your side. Okay.
Okay. One of my favorite things about the customer support team is that if I call somebody with a question and they don't know the answer, they find somebody that does.
Hmm.
They're
That
very
was
good
one
at
of,
that.
yep. That was one of the most important things that we instituted. And that was, if we don't know an answer, we escalate to someone who does, because the last thing we want to do is give people wrong information.
Right.
So thanks for acknowledging that. Yeah.
I was impressed by that every time. The other thing, the other night, I guess it was Monday, I think you were talking about how the Motus hand helps, or even the foot helps us get our function back, neurologic function back from the peripheral to central.
Hmm.
And that's just contradictory to everything I've learned. Because I always just thought we got it back from central to peripheral.
Oh, I think the natural progression is certainly that, right? If you are just left to your own devices,
Right.
and you rely on basically sporadic recovery or spontaneous recovery, the
Right.
processes generally go central or sort of proximal to distal.
Right.
Now, with respect to drive interventions, you can actually get recovery the other way around. And it actually ends up being a bit more advantageous that way, because if you can drive interventions to the distally, you'll get that recovery proximally, which is pretty
Right.
interesting. Yeah.
But how does that happen though?
In what way?
When you drive it distal to peripheral?
Oh, sure. It's actually probably a complex interaction of various things. One of
Okay.
them is actually, that's not surprising. I don't know why I would say that. It's, of course, it's a complex thing, right? It's biology, and it's the nervous system. But what happens is there's this concept called learn non-use, and
Okay.
learn non-use is basically, after neurologic injury, we will preferentially use our stronger side.
Right.
And that means that we basically just de-emphasize the use, in your case, of your left arm. And
Okay.
that causes this sort of really poor negative feedback loop where you continue to disuse that left arm. And that
Right.
causes all those plastic changes to happen as well, right? Everyone thinks neuroplasticity is great, but the thing is plastic changes can go both ways, right? It's really expensive to have muscles, nerves, and all those networks stabilized and functioning, right? It's
Right.
very, very costly. And our genetics and evolution says that we need to do things that are not very expensive because we want to survive. And so
Right.
when you don't use something, you get all these sort of snowball effects of those tissue changes that are occurring, and you will basically deregulate a lot of the proteins and the receptors that keep those neurons functioning and connected. And so you get this
Okay.
big constellation of changes that happens. And when you are using your arm distally, for instance,
Right.
what you do is you revert a lot of those changes from happening. So not only are you driving changes specifically to that area, so causing activation of those neurons, but you're also reversing this behavioral phenotype that causes those problems to be amplified. And that's, of course, an oversimplification of the whole process, but I think it's at least a fair entry level discussion to why we see those types of improvements.
Okay. It's complicated, but that was it in a nutshell.
Yeah, yeah, yeah. And of course, I've had many talks, given presentations about this stuff. There's some really nice work about how, actually you're probably familiar with this, the somatotopic map that's in our brains, right? The
Yes.
somatotopic map is an oversimplification, and in fact, when you start to actually peer down into things, it's fairly not true. At the cell level, the somatotopic map does not hold. So it's pretty interesting. And what does hold is that they're actually, the organization is not at like a discriminated, here's a hand area, here's a finger area, whatever. It's actually at a function. It's actually at a functional level when you go down to look at individual neurons. And this is some really seminal work that came out of Kolasko and Georgopoulos' labs back in, let me see, late 2000 or early 2000s.
So does that apply to both the sensory and the motor map?
Slightly different. They're slightly
Okay.
different, but the motor maps are very much like that.
Okay.
Yep. So when you look down and you actually can do activations, and of course we do this in usually in non-human primates, but those various neurons that are activating, they kind of get activated in functional groups instead of just pure somatotopic organizations.
Okay.
So yeah, it's some cool stuff. Okay. Well, Lori, I'm going to have you actually go through and play some of these games and just, I'm going to watch and see how things are going.
Okay,
And
I'm
I'm going to
playing
go,
strongman right now.
good.
And that I'm
Yeah,
not using my right hand to help with that. I'm just doing it all with my left hand.
great. Very good. Okay.
And
Very good.
it's working. It's still working very efficiently.
Very good.
I still can't
Okay.
believe how much I can extend my wrist without feeling it. That's
Yeah,
amazing.
it is. It's quite a thing.